So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 348 and in this video we continue with our move assignment operator, and for that again here in CPP reference.com we go to the language section, here in classes down to move assignment, and we start with the syntax now. Okay, and let's get started. First of all, we have here a declaration, and the explanation is here down of all the numbers here. The declaration starts with a return type. Let's read this. The return type should be a T ampersand, which means it is a reference and an for an L value. Okay, then we have the operator, because we have here an operator overloading, and the operator which we want to overload is the assignment operator here. And we want to give this assignment operator our own functionality later in the function body. And then we have the parameter list, and you can see the parameter list is similar to the move constructor. We are only allowed to bind to an R value, which is an R value reference, but of course we can have this word const, volatile, or even const volatile and so on in it. And we go to the next. Here we have almost the same like here on top. You can see this here, it's the same part here. The only difference is we have here a function body, which means we have later these curly braces here, and in the function body we will put in our code. And the difference here about this one is called a declaration. If we have a function body, we call this a definition. Okay, and the next line again, the same, almost the same like this one here. The only difference is that we have here a parameter list which should not have default values in it, so it's not allowed. And the next difference is we have the word default. So first of all, let's go to the parameter list no default. It is described here. So you can see it can only have this, again, our reference, R reference, but you are not allowed to give it just a default value. And the next thing here, this default, we learned this also. You can force the compiler to create a default, in this case, move assignment operator, because sometimes we know the compiler will not create this. And here in our move constructor example, I go back here to the move constructor. We talked about this in one of our other videos. You can see here the struct D, we talked about this one. And the struct D has here created, for example, a destructor. And if you provide a destructor, then the compiler will not create an implicit in this case implicit constructor, but with the word default here we can force it. And this is the same like here. If you have a move assignment operator and the requirements are not met, so that the compiler can't create again an implicit assignment operator as a move assignment operator, then with default you can still force it, and this is the way to do it. Okay, and the next line again, the start is almost the same like here. The only new thing is again this word delayed, and delayed means here in this sense again you are forcing the compiler not to use a move assignment operator, even if it's possible. So there are scenarios you don't want that the compiler is moving. The compiler should perhaps copy all the content, you just want it, and so you can do it with this word delayed. And this one is also super easy, because you can see this is this part, this here is this part, and the only new thing here is really this one here, and we already learned this as well. This means the operator is not in the class defined, perhaps outside, and with this scope resolution operator we can find it. And here you define in which class and then where in the class, what in the class. So this one is also here explained. Let's see if it's explained. No, it's not, but this is just outside of the class. I think it's defined here outside of the class definition. Okay, and the next line is also defined outside of the class. You can see this part is almost same like this part. The only difference is the parameter list no default, which means you should now provide a default argument in it. And we have again the word default here, so you can make an outside with default as well. And like I said, the nice thing is this move assignment operator is very similar to the move constructor, so we will see a lot of similarities here down the line. and we go on. Okay, I'm skipping here this part. You should read this, but I jump directly to this example here, and let's get started. First of all, we have here struct X, and inside we have just defined a move assignment operator. And with this syntax, you should realize what it is instantly, I hope. It is just a declaration. Look this, it looks exactly like this. The only difference is now all these things are just they set the real values there. For example, return type, yes, is x ampersand, because it's all time, and not all time, but most time, the value from here. So x, I return this one. And then the parameter list is included, okay. The R value which we have, and only one argument here, parameter here. And here in the next line they show an error because the parameter list is wrong. We learned this as well already. You have to follow the parameter list order, which means it should start with an ampersand and of the class name, and you can see here x and the ampersand and the variable name. Okay, let's go to the next example, and we will skip the word union here because we have not talked about it and we need a special video for it, because this word union is a very special case and it's not often used, but when it's used you need to know how to use it. But we can still jump to the next example here, and we have here a problem. This looks not one of our definitions. So when we compare this one here with this one, that looks not really the same. This comment here already tell us what it is. It is a trailing return type. That means, first of all, an operator overloading is just a function, but a special kind of function. And in the section of functions, there is also this trailing return type function. And what is that? Actually, it is simple. First of all, we have this new thing here at the end that looks like a pointer, but careful, this is not a pointer with a function. It is a trailing return type indicator. We expect this one here as our return type. But when we watch here the start, there is not a return type. We use the word auto, and we know already what auto is doing. Auto is a word for the compiler, so the compiler should figure out what the return type of this function is. And when we combine now these two infos, we say, hey, compiler, I give you the word auto, you should figure out what the return type of this function is, but with this one, I tell also the compiler, I expect that the return type of this function should be this one here. Many would say now, okay, wait a minute. When we already expect this return type here, why not just write this return type directly here? Actually, in a normal case, when you have something like that, you would do that. You would not write here this trailing return type, you would just write this return type here directly. But why they do this in general then? And the answer is this trailing return type is used in other places where it matters more, like templates. For example, in a template, you have there this function, and in the function body, you have two different types. And these two different types will be anyhow combined, and the compiler don't know which the outcome is, and then you can say, hey, I expect this outcome, only one type, not the other type, and you can make this then in this way visible for the compiler. But again, we will talk about this more when we talk about compiler, because then you will see a lot of trailing return types with this here. But let's go back to our move assignment operator and check if this one looks now similar to one of our definitions. And how we do this? First of all, we know now, okay, this one is normally here at this point. When I put this one here, then I have here my return type, okay. Then I have my operator, okay. And then I have also my parameter list, okay. So with other words, we have this one here on top, which is a declaration because there is no function body. And it looks here different, but actually it is just this one here. Okay, the next example is a little bit difficult and I want that you research this a little bit on your own, but what I can say here first is this here is probably not recognized by the compiler as a normal move assignment operator. What I mean with that is you as a programmer can use this line here as a move assignment function. So you can call it and this here will perform a move assignment operator for you. But the compiler will not call it, and the question is why? The answer is it is following not at least the normal syntax which we learned. So we can watch the syntax again. Here important is the parameter list, and we checked here the parameter list should be at least this one here, and important here is this part here should be on the right hand side. And when we go down here to our strange move assignment operator, we see this one is the right hand side but without double ampersand. So it is not an R value, it expects here an L value. And this is wrong. I show you this a little bit more concrete. Here we have the left hand side with this one. This counts not because the left hand side is the object itself, and this is also a little bit weird. That's why I said this function here is a little bit difficult. But let's I show you this here down in the example. Here we have created two objects, and then let's jump here to this one because that looks easier. And then we have the right hand side we create with A1, which is an L value. We convert it with std_move to an R value. You can see this is now an R value, and now we try to assign it to A2. This one here is the right hand side, an R value. And an R value, when we go to the syntax, will all time match this parameter list which we have here, which is also specified here. And this one here will not work. This is the right hand side, and the right hand side again is this part in this example will just say you are not an R value, because this function here, which perhaps the programmer provided, expects an L value. Okay, and here we have the last example, which is just almost right, but you can see we have here a problem. It is a non-object parameter, and this is violating the parameter definition. Like here on top, there is only one parameter, which is of the type this one. We have here this one parameter. The problem is we have here one more parameter with a default value, which is not allowed. Alright, that's enough for this video, and like all time, if you have any questions, write in the comment section. See you next video. Bye and good luck.